So yesterday we were doing this problems of substitution method. Okay, let's start with today's session. So we'll continue with few more examples on substitution method, slightly different one. So if you want to evaluate this one, root of tan x, root of tan of x divided by, you have sin x into cos x, sin x into cos of x, root of tan x divided by sin x into cos x. Now, if you try to observe, in the numerator you are having tan, that under square root. Now, the question is, can you make that denominator also in terms of tan so that you can integrate that one? That is one way of doing it, right? So let us try to see how exactly to actually make the denominator also in terms of tan itself. So we try to observe over here. So the only way that I can solve this one is put this under root value which is there. If you want to put this under root value to be tx, then derivative of tan will be what? We know derivative of tan. Yes, secant square, but you don't have the secant square value there. So I have to get this value. I have to get the value. That means the denominator sin x into cos x has to be converted in the form of secant. So now the question is how to convert this in the form of secant. All right. So in this case, you have to simplify only the denominator because the numerator you cannot change because it is under root. Because it is under root, then the procedure will slightly change. Multiply and divide by cos. So if we try to multiply and divide by cos over here, multiply and divide by cos. So this is something extra that you're doing, multiplying and dividing by cos, right? But in the denominator, what you're having sin x into cos x. Sin x is already there, but I need to even write down that cos x as it is, no change. The only additional thing that I'm doing is multiplying and dividing by cos. So let us try to rewrite this one. Into dx will be as it is there. This will be equals to, it is integral of, now this is root of tan of x, root of tan of x as it is, its whole divided by. Now if I try to group this value, which is there over here, sin x by cos x. This sin x by cos x will give us tan. So therefore I can write that as tan of x. Whereas the other values which are there over here, cos x into cos x, you can group these two. When you group this cos x into cos x, you'll be getting cos square of x into what you're having into dx here. Or further, if you try to simplify this one, this will be equals to, it is root of, that is root of tan of x divided by, so tan x can be written as root of tan x into root of tan x, root of tan x into root of tan of x. Now this 1 by cos square can be written as secant square of x, secant square of x into dx. But further what can we do is, because you are having root of tan x, root of tan x, I can cancel out the root of tan x and root of tan x. I'll be left out with under the integral 1 by tan, root means to the power of half. Whenever you write down root, root represents to the power of half. This secant square of x will be as it is into dx. But because tan is in the denominator, if I take that in the numerator, the positive power which is there, the positive power will become negative power. Plus half when it comes to the numerator, it becomes minus of half into the secant square of x into dx. Now let us try to see, can we put this value tan of x to be t. Tan of x will be equals to t. Now if I try to differentiate, I have to get back this secant square. We know differentiation of tan will be secant square. Therefore, you'll be getting secant square of x into dx will be equals to dt. Now let us try to plug in this value back there in the given integral. You'll be getting integral of tan x. There are two ways in which you can express it. Directly, you can write here itself, you can put tan x to be t and continue. But again, you have to further simplify it in the form of, if you know the formula of 1 by root x, then you can go ahead. Otherwise, again, you have to express the t power of minus half. Taking t to the power, instead of taking tan, you'll be taking t in the numerator and making that value to be equals to t power of minus half. Instead of doing at that step, I'm trying to do at this step only. That's the only difference. So now if you just try to plug in this value, it is t power of minus half it is. And secant square of x into dx will give you dt. But now we know this formula. So that is integral of x power of n into dx. X power of n into dx. It is nothing but x power of n plus 1, x power of n plus 1 by n plus 1 plus the constant of integration c. So now in the value of n in this case is minus of half. So if you just try to plug in there, it becomes t power of minus half plus 1 divided by minus half plus 1 plus the constant of integration c. But the value of t that I have taken is tan x. So tan x to the power of, and minus half plus 1 will give you half only, and it is divided by half plus the constant c. But divided by half, if I take that in the numerator, it becomes only 2. 2 tan x to the power of half, or that power half can be written as root of tan x. So 2 root of tan of x plus c. This gives us the final answer.